Bienvenidos, Ushamdi, and welcome CTS231, Section 841 students for the second 8-week term of the fall 2017 semester at Anne Arundel Community College. This is the Networking 4 course, or the Connecting Networks V6 course from Cisco Networking Academy. And this morning's Packet Tracer video tutorial and solution set is going to be on Packet Tracer Activity 2.5.1.2, where we're going to be doing the Skills Integration Challenge from Chapter 2, and we're going to be called on to do a number of different things in terms of VLANs, a little OSPF v2, and a little OSPF v3. And so let's go ahead and dive in here. And I am going to make a minor adjustment here to give us just a little more space with our description. You can see we have our addressing table here at the top like we normally do. And so the first thing that we're going to be asked to do here, and it says use the Cisco and class passwords to access privileged exec mode. So this is very important here. Remember this, if we have to access something for the routers and switches, the Cisco and class passwords will be for the privileged exec modes, so we need to be aware of that. And so we have an addressing table here. Now, it's talking about the addressing scheme. We're using the 192.168.1. However, we've broken that down into some subnets, into smaller subnets. And you can see here we have the subnet address, also referred to as the network ID, right? The net ID. And you can see we start with the 192.168.1.0. We've got a blank here on 25, so we've got some subnetting work that needs to be done before we can progress. So if we start here, right, this is going to make logical sense, and let's figure this out. So we can see that the 192.168.1.0 has been subnetted down, and the first subnet uses a /25. Now, don't be fooled by the hosts column over here. What this is saying, this is not indicating how many usable IPs we're going to get out of this subnet configuration. This is simply the number of hosts that we need to accommodate or be able to provide usable IP addresses for in the subnet. And so this is driving the size of our subnet. So if we start out with the first, the 192.168.1.0/25. Remember, the /25 is indicating the number of network bits. So if I was to say 4, 1, 2, 3, 4, I think that's 8 there. 1, 2, 3, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So there's 24, right? That would be a /24. But now we've got this last octet here. And in a /25, we've borrowed the first host bit. And remember, we're forced to go from left to right when borrowing the bits, borrowing host bits and changing them into network bits, meaning that the final 7, 1, 2, 3, 4, the final 7 bits, these, and I'll do my best here to call those out, these 7 bits, those are what's left over for the hosts. Now, very important here, and this is a very easy way to figure out what I like to refer to as the block size, right? The block size for the subnet. And that is by taking the number of host bits that remain and using that to raise 2 to the power of the number of host bits that remain. So 7 host bits are remaining. And so I take those 7 host bits, I do 2 to the power of the host bits. Well, 2 to the 7 is what? Well, it's 2 times 2 times 2 times 2 times 2 times 2. And let me make sure 1, 2, 3, 4, 5, 6. And 7, and if we were to work that out, 2 times 2 is 4, 8, 16, 32, 64, 128. So this gives me my, I'll put block size, right? That's the block size. So I know that the network identifier is .0. I know the block size is 128. So what that tells me is the first subnet, and I'm looking for some space here. Let's come up here. The first subnet would be .0. The next subnet is going to be .128 because that's the block size. And it's the block size, so we basically add the block size to the preceding, and you're going to see that this is going to happen again, right? Because we're going to have some different network IDs here that we're working with. So that we know that the first network ID is .0. It's given to us here, right? We know the block size because we've just figured out that little shortcut formula to determine the block size of 128. And that means that we basically go up 128 from the preceding subnet ID to get the next subnet ID. And what this gives me is this, the broadcast address, because it would end at 127. And remember, there's a couple of little tricks that you can use here. Remember, the network ID is always, always, always an even number. So the subnet ID will always be even. The broadcast address is always odd, an odd number. So 127, 129, 131, it's going to be an odd number. So here is the entirety of our first subnet. And so now that we have the block size and we take a look here, you can see, okay, well, there's nothing else here that starts at 128. So that tells me that from a network ID perspective, that this is going to be 192.168, and I'm running out of space quickly, .1.128, right? And now that we know that, right, we know that we need at least 50 host IPs. Well, 2 to the 7 gave us 128. Now remember, let me make sure I'm clear on this and I break this down. This right here, what I just did right here, is for the block size. But if we make a minor modification, we also get the number of usable host IPs. And to do that, right, we're going to use this same 7 host bits, and we simply take 2 raised to the number of host bits minus 2. And again, a little review here from subnetting. What is that minus 2? What is that 2 representing? Why am I taking 2 IPs or 2 things away here? Well, I'm taking 2 away because we have the subnet ID and the broadcast address. Are those usable? Remember, these are the usable IPs that we're trying to figure out here. So I subtract 2. 1 represents the broadcast address, which I can't assign to a host. And the other one represents the subnet ID, again, that I cannot assign to the hosts. So that's where that 2 comes from, the broadcast address and the subnet ID, or the network ID, the network identifier. So we have to take those 2 guys out. So we know 2 to the 7 is 128. I subtract 2, we get 126 usable IPs. So inside of a /25, specifically this /25 subnet right here, we can have 126 usable IPs, which is definitely going to meet the requirement. Remember, that's the requirement there, that we have to have enough usable IPs to accommodate 100 hosts. So now when we come down here and we take a look, what do we see? Okay, well, I need to be able to accommodate 50 hosts. Well, a /25 would definitely work. But if we're switched on, right, if we're paying attention, you would know that a /24 can give us a maximum of 2 /25s. And the reason I say that is because the block size, again, right, this block size is critical. Because if the block size is 128, if I added 128 to this, it would go up to what? 256. That is not valid, right? And that would be it. And so it would be 255, and then that would be the last subnet that I could have in the 192.168.1.0 address space, right? That /24 that we're subnetting. So we can't do that. And now I'm going to hopefully be able to pull that back and pull those back. Okay, that's as far as we're going to go, so I'll do this here. And so that's why this would work, right? But is that the most efficient use? And maybe, it doesn't say that here, but really that's what they're implying, is that we've got these other subnets in this space, so we need to make sure we can accommodate those as well. So 2 to the 7, right, with 7 host bits and only 1 bit borrowed for the network bit, that yielded 126 usable IPs. So it's a pretty easy equation. Let's just step it down 1, right? Because if 126 is too many, and not only too many, but it's going to blow up our other subnets that we've created, let's drop it to a 2 to the 6. So 2 to the 6, which would be 2 times 2 times 2 times 2 times 2 times 2, right? That would yield what? 64. So our block size, I'll just put BS there, the block size is going to be 64. The number of usable IPs would be 2 to the 6 minus 2. And that gives us 62. Now, does that meet the requirement for 50? Is that the most efficient subnet that we could come up with? And yeah, it is, because if we step it down to 2 to the 5, we get what? 2 to the 5 is 32. And we already know that's not going to work. So the most efficient use and the only subnet size that will work inside of this existing configuration, right, this existing subnetting scheme, is going to be a /26, right? So we would end up borrowing the next bit here, the second bit. And that gives us a /26. So we've got 6 host bits left over, right? So we have 62 usable IPs, but this is where it's critical. And this is, again, a great shortcut that makes it very, very simple, is we see our block size is 64. So just like we did here, where I added 128 to 0, because we were starting at the .0 subnet, I just add 64 to 128 to take me to the next network ID, which is the one that we're looking for. So what is that, 64? So it's going to be 2, and then we're going to carry a 189 and 192, right? Now, what would be the broadcast address here in the second subnet range? Exactly, it would be the IP right before that network ID, so 191, and it's going to be odd. And do we have that subnet here? We'll take a look. Absolutely we do, right? 192.168.1.192, and you can see that it also this one is a .224, which is going to be a /27, and then this guy's going to be a /27. And so we know that the next network ID, right, if the block size is 64 here, and that takes us up to this next network, which is a 224, we would say 128, 192, 224, right? We'd borrow a third bit for that subnet. What's my block size? 2 to the 5 is 32. So 192 plus 32 is going to give me 422, 224. And then the final /27, right? And you can see here the network ID starts at 224. And so before we get there, this is going to be 223 for the third subnet. And then this last subnet, it would be 32. When we add 32, we get what? 256. So we know that this is the last subnet in the range, so it's 255, right? So here are the 4 subnets that we're going to be using. This is going to be VLAN. Let me make sure I get this right. They've moved it around. This is VLAN 15, and the 128 is going to be VLAN 25, and then the 192 is VLAN 1. And the 224 is VLAN 99, right? And so that's how we break down that subnetting range. And so you can see here, it says complete the addressing table by assigning the following addresses to VLAN 25. And so we get some addresses here. So the router 2 gig 00.25, the first IP, well, what is our first usable IP in this range here? Right, remember the subnet ID or the network ID and the broadcast address, these are not usable, quote unquote usable, right? We can't assign these to hosts. So .129 is going to be the first address. So .129 is our first usable. PC25 gets the second address, which is going to be .130. And L25 gets the last IPv4 address. And this is critical. L25 is, it looks like a laser printer actually. Now, the last IPv4 address is not the broadcast address. Remember, we're talking about the last usable IP. So that would be .190. And so we're going to do those configurations, but I'm actually going to write this down that way because as soon as I clear the screen here, you know that I'm going to end up forgetting these. So .129.130 and .190. All right, so we are good to move forward from here. There's the subnetting breakdown. That's how we would come up with those numbers. So let's go ahead. Let's get router 2 up here, and let's dive in on some configuration work. Give ourselves a little more space. A lot of work on router 2, so we're going to take up the most space with that. Now, the password, it was Cisco, right, to get into user exec mode. When I go into privilege exec, we're going to use class, and that's going to get me into privilege exec. So let's jump into global config. Let's do a do show IP interface brief, and let's see what we've got here. So you can see we've definitely got a router on a stick configuration for our inter-VLAN communication. And the serial interface is up. Everything else is administratively down. So let's handle this first. Let's get into gig 00 because that's clearly where all of our sub interfaces have been created. And let's say no shut. And let's bring that interface up. Now, it's tough to see here. You can see we've got some spanning tree action going on over here where this is orange right behind the F01 label. We're green here, and this will come online in due time while we're doing this configuration. Now, first thing we're going to do is gig 00.25. And let me do a do show run. And let's see, have they done... yeah, no IPv4 addressing there. And interesting, it's missing the incap.1q commands. Okay, so let's see. They may ask us to do that. Okay, so here's how we're going to approach this. So we're here on gig 00.25, and this is where we want to put in. I'm going to say incap.1q, and let's see if they actually provide any points for this. Incap.1q25, which we're definitely going to need. And yeah, there are points for that. So this is definitely something that was missing from the configuration. And let's say IP address 192.168. And so all of that subnetting work that we did to give us the 129. Now remember, we know that this is a /26. So 255.192, right? Because 128 and 64 is going to yield 192 when you add 128 to 64. And when I hit enter here, we should also see, yeah, we got 4 points for that actually. Okay, so it says complete the addressing table for VLAN 25. So let's walk through this in turn, but then we're going to step back because those incap commands are missing and we need to make sure we get those in there. So PC25, which is a member of the VLAN 25, is going to get the second, oops, sorry, we didn't want that. I apologize. We're going to take that back. We're going to come over here. We're going to do a static 192.168.1 dot, and I'm looking down here, 130 is what we used. And again, subnet mask. And when you hit tab like that, it puts in the default subnet mask for the address that it sees, right? And so 192 is a class C, so it will put that classful mask in there. However, we are subnetting that class C. Now, it doesn't say to put the default gateway in. However, we know that we're going to have a default gateway if we have any hope of getting to anything outside of VLAN 25. And so what would the default gateway be? Exactly, it's going to be the sub interface on gig 00, specifically gig 00.25, because that is the sub interface that represents VLAN 25 on router 2. And so we just assign that 192.168.1.129. And I'm curious to see, yeah, and that was actually 2 points right there. So they're definitely expecting you to enter that in. Now, DNS server, no DNS server information, so we should be good. Now, before we leave here, let's do this. Let's see. Can I ping 192.168.1.129? In other words, can I ping my default gateway because I've got it properly configured, and we cannot. Now, the reason that we can't is probably right here. The answer to why we can't do that is right here to the left, VLAN and port assignments. We haven't done any of that, and so that tells me that here on switch 1 that work's probably not done yet. But again, it doesn't hurt to check to see, hey, can I ping my default gateway? Now let's go to L25, which I'm assuming is a laser. That L stands for laser printer. And here's the static address. Now, interesting that it knew the default gateway already, right? So it knew what the default gateway was, DNS server. Now this is interesting. Global interface, interface fast Ethernet 00. Here we go. Yes, that's kind of interesting, right? When I was under the global settings, so for global, they've got a static gateway, but you have to click on fast Ethernet 0. So again, a little quirky, but we can deal with it. So what is our IP address? Remember, last usable IP in that range, 192.168.1. What? Was it 191? No. Remember, 191 is the broadcast address. We want that last usable IP, and that was for, got 2 points for that. Now let's also get the dotted decimal notation for the subnet mask in, which would have been a /26. So that was going to be 255.192. Again, I'm coming up with that 192 because we ended up borrowing 2 host bits and flipping them to network bits. And the 2 bits that we borrowed was bit position with a value of 128 and the bit position, which was immediately to the right of it, with a value of 64. So when we add those 2 guys together in that final octet, we get 192. And we did end up with points for all of that. So we've got the laser printer configured. I'm not sure what they're expecting us to do with the laser printer other than configure that, because it's definitely not going to print anything for us. All right, so configure IPv4 addressing on the necessary devices, or necessary in devices. Now, the in devices have got to be L25 and PC25, and it doesn't say anything about PC15, so it's worth taking a quick peek here. Okay, so PC15 already has configuration, right? And these would be the in devices. So I'm reading this and I'm thinking that we're done on the in devices. Now on router 2, create and apply IPv4 and IPv6 addressing to the gig 00.25 interface. So I'm going to have to roll back just a skosh. And let's get R25 up here. Do show IP interface brief. I'm going to walk through. Do show IP interface brief. Whoops. Do show IP interface brief. So we're going to walk through each of these because you can see, is any IPv4 information assigned to any of these? And the answer is no, right? We've only done 0025. And when you look at this, it talks about the route. Yeah, so it doesn't actually specifically state beyond this step right up in here. It does. Oh, okay, wait, here it is. I was looking for it. On router 2, configure inner VLAN routing. And VLAN 99 is the native VLAN. All right. So we'll do the IPv6 addressing here, and then we'll keep gigabit 00.25. We'll stay in line and follow through sequentially with what they're showing. So we need our IPv6 address information, and here it is right here, right? That 2001 DB8:A, and I kind of like how IPv6 address 2001:DB8:A:25. I'm leaning in to see that a little better. :25:1/64. And then we're going to do a link local address, IP address, FE80::2, link local, right? And so we put the link local address in there as well as the global unicast address. And I'm, again, just kind of looking here at that addressing table, making sure that that's everything we were expected to do for this step. All right, so we created and applied the IPv4 addressing to the gig 00.25 subinterface, so we're good there. So now we're going to deal with some VLANs. I'm hoping that this switch is going to accommodate me with larger print, and as you can see, we are not going to be so lucky. So I will definitely, as always, MC us through this, as this is very tiny here. So Cisco to go into user exec mode, and then from user exec to privilege exec with the enable command. Remember, it's class, Cisco and class. So now we are on switch 1. So we're going to create VLAN 86 and name it black hole. All right. We go into global config. We're going to say VLAN 86 name, and I'm going to make sure we are right spot on here with the black hole with the capitalization to make sure that we get all the points there with the name of black hole. So configure switch 1 ports in static mode with the following requirement. So fast Ethernet 01 is the native trunk for VLAN 99. And again, that makes sense, right? Because this is the trunk link across which all of the VLANs are going to go to reach router 2, where we have a router on a stick configuration for inter-VLAN communication. And so basically think of it like this. If PC 15 wanted to talk to PC 25, the traffic is going to go like this. It's going to come down to the switch. It's going to go to its default gateway that's configured, which is for PC 15 192.168.1.1 on the sub interface gig 00 dot, and I want to say it's dot 15. Yeah, it's dot 15 up there. And it's going to come into the router, and the router is going to say, oh yeah, I know how to get to the 25 VLAN. I'm going to go back out that trunk interface, and we're going to go this way, right? And that's exactly how communication would flow. And then communication in the reverse direction between these two is going to go the same way, right? And that's how the traffic is going to flow. It is not going to flow like this. It doesn't come down to the switch and then go like that. It comes to the router because the router's providing inter-VLAN communication. We have VLANs here, remember, right? And the VLAN is a logical separation of the networks. That's what we're doing at layer 2. So we need a layer 3 device to get between the VLANs. Okay, so let's clear that out there and let's bring that back. So we are on the switch. We've done VLAN 86. So Fast Ethernet 01. Let's take a look. Let's see what Fast Ethernet 01 looks like here, and I'll kind of tell you that there is absolutely zero configuration on Fast Ethernet 01. So interface Fast Ethernet 01. Now, it says static mode. Configure switch 1 ports in static mode with the following requirements. So we're going to say switch port trunk in cap .1q. Now we get an error. Why is that? Do show version, and my guess is we've got a 29. Yep, it is a 2960. So the only encapsulation type that we could put on a trunk port is .1q. It's the default, and it's the only option, right, on the newer Cisco switches, the 2960 being one of those switches. So we don't need to put switch port trunk in cap .1q. We need to say switch port mode trunk. And we should probably, yeah, we see some points for that. And that is statically configuring. Now, I am also going to say switch port no negotiate. I'm going to turn the dynamic trunking protocol off because we don't need it on. And I'll be curious to see, because again, I'm reading into this quote unquote static mode that they're referring to. So let's see, does switch port no negotiate result in any additional points? And it does not, and that's fine. So switch port trunk native VLAN is 99. So F01 is the native trunk for VLAN 99, so we'll get that in there. And then I'm pretty sure we're up, so we'll say no shut. And then let's see what we've got here. So we've got switch port trunk native VLAN 99, switch port mode trunk, switch port trunk no negotiate. So now let's come back to PC 25. And can I ping my default gateway yet? Now, we probably shouldn't be able to. And it doesn't look like it's going to work, and so I'll let the second one pop up here, the request timeout. We'll let that one hit. There we go. Yeah, it's still not going to work because what haven't we done yet? Yeah, we haven't put these ports into the correct VLANs yet. So let's bring the switch back up. And the next step is fast Ethernet 07 to 018. These are going to be access ports, and they're going to be in VLAN 15. So I'm going to say interface range, fast Ethernet 0/7 to 18. Let me make sure I got that right. And we do. So we're going to say switch port mode access, switch port access VLAN 15. And then let's go ahead and say no shut. Whoops, no shut. And so those ports are all up. They're access ports. They're in VLAN 15. I'm also going to do this. I'm going to say, not switch port, I apologize. I'm going to say spanning tree port fast. That way we're not waiting around for things. And I'm going to say spanning tree BPDU guard enable, because these are host-facing ports, right? So we want to skip the listening and learning phases of spanning tree, and we want to go directly into the forwarding phase, right, into the forwarding state. And it's safe to do that. And again, this will save us time if we have to bring any of these ports down and bring them back up. So we've got that taken care of. Let's say do show run. Let's see where we're at now on there's 7, 8, 9, 10. Everything looks good there. So with PC 15, should I be able to ping my default gateway 192.168.1.1? I think we should. And let's see if we've got an ARP timeout there, request timeout. Can we ping through yet? And we cannot ping yet. So it may be, and you know what I didn't even look at? Let's see, do we have do show VLAN brief? All right, customers is good, employee 25, black hole 86, default is 1. All right, so we'll go ahead, we'll stay in order here. Oh, yeah, I apologize. We've got the router 2 config that's still ahead of us on the sub interface. So this next command on VLAN 25, we should be able to ping through. So interface range, fast Ethernet 0.9/19 to 24. And I'm looking back over here. So again, switch port mode access, switch port access VLAN 25. And right here is really probably all they're looking for. I'll throw a no shut in there to make sure all those ports are up. But again, I'm going to say spanning tree port fast and spanning tree BPDU guard enable. Again, those last two commands, port fast and BPDU guard, best practice on host facing ports, on in node facing ports, right? So I'm going to throw those in there just for good measure. And now for VLAN 25, because the sub interface is properly configured, we have connectivity, right? So we can ping our default gateway. And that's a good sign. So let's finish out with the next range interface and do show run. Let me make sure I got that right. That should be 19. Yeah, 19, 20, 21, 22, 23, 24. Okay, good. So now it's so gig 01 and 2 and fast Ethernet 02 through 6 are unused. They should be properly secured, right? And by quote unquote properly secured, it means shut down and assigned to the black hole VLAN. So let's make that happen. So interface range, fast Ethernet 02 to 6. Is that right? Yeah, comma, GI01-2. So I'm going to say shut down. We're going to bring all those interfaces down, and we're going to say switch port access VLAN 86. And so that is how you put those into the black hole VLAN. All right, and that should do it on that piece there. So now we're looking at router 2, and this is where we're going to get into the inner VLAN component of what we're doing here. And so you can see we're going to need to do the inner VLAN on 00.1.15 and .99, keeping in mind the one thing that I always seem to miss is that gig 00.99, that is the native. So we need the native keyword at the end. In fact, let's do this. Let's do 99 first so that I don't forget it and have to scramble back and do some recovery at the end there. So I'm actually going to bring this just down a skosh here. so I can see the addressing table. All right, so do show IP interface brief. Do show IP interface brief. And let's go interface gig 00.99. We'll take care of this guy first. Say no shut, even though it's up. I always type no shut habit just to be sure. And what are we doing here? It doesn't give us, so we're going to use, it doesn't tell us what address to use, but you can safely assume it's going to be the first address in that range. So what do we need first though? incap.1q 99 native, right? 99 is the native VLAN here. So we should see some points from that 43, and yep, we bump to a 45. Let me say do show run. Do we have any IP address? I think it's the V6 addressing that's there. Yeah. So the V6 addressing is there. If we were to validate that, it looks good. 99.1 and then FE80::2. Yeah, so it looks like we're in the IPv4 addressing. So IP address 192.168.1. Now, the subnet ID is 224. The first usable here is 225. And remember, we are a /27, but they give us the dotted decimal notation over there of a 255.254. So we plug that in, and we should bump from 45 points to maybe 47, and we do. And so again, we got the incap.1q native on there correctly, and we've got the IP address 192.168.1.225, and we got that correct. So we plucked off that first usable IP. So now that should do it for that sub interface. And now let's go ahead and get into VLAN 1, Gigabit Ethernet 00.1. And so let me confirm again. I apologize here. 00.1, yeah, that we're just missing the IPv4 and the incap.1q1. And so the IP address would be IP address 192.168.1 dot. And what is the, what am I trying to say here? The default gateway is going to be what? That first usable IP would be .193. And they give us the /27 notation, which we're familiar with, that 255.255.255.224. So now, do show IP interface brief, we should only have left 15. So gig 00.15, and this is going to allow me to ping with PC15 when we're done here. So incap.1q15, IP address 192.168.1. And actually, we know that it's going to be .1 because it's a 15 is the network ID of 0, so the first usable is 1. And the subnet mask is 255.255. Whoops, give some space there. It's a /25, right? We borrow the first host bit that has a value of 128. And so we get that in there. Now the points did not move. IP address 192.168.1.1 for VLAN 15, 255.128. Let me take that off real quick. And it didn't like, how come it's not letting me take that off? 192.168.1. No IP address. 192.168.1.1. 255.255.255.128. So interesting that it's not going to let me remove that. I didn't see the points move, and that's what has me a little concerned here. I want to make sure that we've got everything in there. So can I ping the default gateway? I can. So we've got connectivity. So everything looks kosher with that. Okay, so I believe that is going to take us into the PPP configuration, or that point-to-point protocol configuration here on router 2 between router 2 and router 1. So let's see. Always a good thing to check. Do show IP interface brief. We've got green lights on, but do ping 10.1.1.2. And I'm assuming that that is going to be the IP address. It would have to be the IP on the other side there. That would have to be router 1's IP. So interesting how they gave .1 to router 2 and .2 to router 1, right? Kind of throw us off a little bit there. So configure R1 and R2 to use PPP with Chap for the shared link. The password for Chap is Cisco. So again, very straightforward. How are we going to tackle this? Well, let's get out of subinterface mode. So we know that we need a username statement. We know the username statement has to match the other router's name, host name. Now, remember, they're probably looking for secret here, right? And we'll see, I'm going to look based off the completion percentage. They're probably looking for secret, but no, that will not work. On real Cisco routers, you cannot, with Chap, do a hash of a hash, because this is going to create an MD5 hashed password with that $1 at the beginning of the hash. You can't send that across with Chap and have it work. It doesn't work. So, but let's see if that's what they're looking for and they want the password of Cisco. My guess is we're going to get points for this. So let's see if the meter from 53 moves at all. All right, and it didn't. So that's a good thing, I believe. I'm going to say no. And let's see if they actually have this right on this activity. R1 password Cisco. Fantastic. Okay, this is great. So they've sorted it out in this activity. It's the previous activity, 2.3.2.6, where they had it wrong. But here we get the points for doing it properly, and that is how you do it properly with Chap. You cannot say username R1 secret. It will not work. It has to be username R1 password. And they gave us the points for doing it properly here, so that's a good thing. So we create the username password statement for the other router, right? Because that's going to be the information that we are looking for in the challenge. Then we go into interface serial 000. We say incap PPP, right? It's going to take it down for now, and that's fine. Then we say PPP, authentication, Chap, and we're done, right? And that's it, right? With Chap authentication, very, very straightforward. We change the incap to PPP. We say PPP authentication Chap. We've created the username password statement for the other router. Now we're going to do the work on the other side of the link. So we come over here, give ourselves a little more space. And let's confirm, right? We should not be able to ping at this point, 10.1.1.2. And that link should be down, right? And I don't mean down. It's up from a physical perspective, physical layer, right? We should see up, down, in fact. So let me pull this up and let's see if we see what we're supposed to see. Do show IP interface brief. Make sure I show you this. Yeah, so we see up. We're up at layer 1, right? Because both routers are sensing at layer 1, hey, there is some kind of a serial cable plugged in here. I've got a connection at layer 1 and it's up. However, at layer 2, the encapsulation protocol, right? We are down. And we are down because one side is HDLC, and that would be router 1, and the other side is PPP, and that would be router 2. And you cannot mix and match layer 2 incaps with a point-to-point connection. They must match. So let's come over, come to router 1 here. And is it Cisco? Yep. To get into user exec, let's go to privilege exec with class. And now we're in privilege exec here. Quick show IP interface brief. Yeah, and it shows up, down on this side as well. And that's what you will see when there is an encapsulation mismatch. Okay, so let's do a show run. Let me see what they've got on this serial interface here. Link to R2, the IP is good. And by looking at this, which side is the DCE side? So let me do this. Do show run, a little pop quiz here. Do show run. And it just popped into my head that this would be a good question to ask. And actually it won't, because they've got the clock rate on both sides. So with the clock rate on both sides, you can't tell which side's the DCE side. What would we have to do to see the DCE side? Yep, show controller, serial 000. And, router 1 is the DTE side. So if I was to say do show controllers, serial 000, we should see what? Yep, router 2 is the DCE side. And again, in this configuration here, this is our internal network. That's fine. It's sort of irrelevant in your internal network which side's the DTE and which side is the DCE. It really doesn't matter internally. Just remember that the DCE side controls the clock rate. That is where that's going to be set. This telco scenario out here, right? We've got this cloud, this ISP cloud. We want that side to be the DCE side, and it should be the DCE side because the telco is going to be controlling the clock rate. They're the ones that are going to control that, not the customer. The customer doesn't tell the telco, hey, this is what I'm doing for my clock rate. It should be the other way around, where the telco tells the customer, this is what you're going to do for your clock rate. All right, and let's finish out router 1 here. Let's get into global config, interface. Oh, actually, before we do that, let's do our username statement. So username R2, and I'm going to say password. I'm hoping that they're going to stick to their guns here, so we should get some points from 59 to 61, and we do, so that's great news there. Serial 000. Change our encap over to PPP, and then we're going to say PPP authentication chap, right? And you can see that the line comes up. So can I ping 10.1.1.1? Fantastic. So we've reestablished connectivity, or I should say reachability, between router 1 and router 2. And so this is a good sign. So let's test this. So from PC25, can I ping the router 1 interface right here, 10.1.1.2? Let's give it a try. 10.1.1.2. And we may time out on the first one, and let's see if we can make our way up there. And we cannot yet, but that's okay. So we'll keep driving on here. So R1 and R2 use PPP with Chap on the shared link, and so we did that, right? Now we're down to the routing section. This is it. This is sort of the last section here. So on R1, configure IPv4 and IPv6 default routes using the appropriate exit interface. So which interface would we exit out? Exactly. It's going to be this interface because this is facing the ISP, the internet here. So let's pull router 1 back up, and we're going to configure default routes for IPv4 and IPv6. So we'll do IP route quad zeros, 0000. And the outgoing interface, serial 00, and then I covered it up and forgot what it was, 1. All right, serial 001. So we should get a few points for that default static route there. And then IPv6 route : /0 serial 001. We should also see some points for that, and we do. Right, so we've got our 2 default routes, and the reason that we're configuring those is my guess is we are going to be propagating those into OSPF, and it looks like we are. All right, on router 2, configure an IPv6 default route using the appropriate exit interface. So for router 2, that is going to be, and so let me see here. They don't have us, yeah, so it's interesting, right? We're not propagating the IPv6 default route that we configured on router 1. That is not being propagated into OSPF, and that is typically how you would do it. For whatever reason, they have us coming down here to router 2 now and doing an IPv, and this is typically why you propagate the default route into OSPF, is to avoid having to do this. IPv6 route : /0, and the outgoing interface is going to be the serial 00 interface. So that is why you would propagate it into OSPF, is so that I don't have to come down to router 2 and add that statement in. I can auto-magically do it by simply propagating it, but when you look down here, they don't have you do that in the OSPF for IPv6 configuration section. So that's okay, we'll drive on here. So configure IPv4 OSPF using the following requirements. For routers 1 and router 2, they're going to be in area 0. So let's go ahead and say router OSPF 1, the process ID, process ID will be 1. My router ID is going to be for router 1, 1.1.1.1. And it says advertise specific subnets. And that is an ambiguous statement if I've ever seen one. Do show IP interface brief. Okay. Now, they don't even ask for the passive interface command. So I'm going to add that in. Passive interface. And we'll say, this is going to be interesting here because this is going to be tricky with the making sure we're giving them what they're looking for. Because, again, when you look at this, we don't need OSPF on this link here. In fact, we don't need an OSPF network statement or the interface subinterface or the interface command because we've got default routes. So we're going to come here anyway. So there is no need for a network statement because we're not running OSPF here. But they're not asking for passive interface either. So here's what I'm going to do. I'm going to say passive interface serial 001. And do we get any points for that? I didn't look quick enough, I don't believe. If I say no, does it take a point away? It doesn't. So I'm going to, well, there's no need to passive it because we're not going to run anything on there. So I'll leave the passive interface statement off of there. And we're going to go ahead and say network 10.1.1.0, 0.0.0.3. Remember, this is going to be the wildcard mask, area 0. And what that's going to do is that's going to start, it's going to run the OSPF process here on this interface between routers 1 and 2, because that's where we're running the OSPF, and that's where we need it to be running. And so we should go from 72 to 73, so that was correct. And I'm just thinking things through here real briefly because that statement, advertise specific subnets. It's like, okay. So really, that is it. There are no other subnets other than this internet subnet, which we don't need to advertise, or we should not need to. So let's do this. Do show run. And that way we don't have to track back. Let me... So it's a /30, so that's going to be the statement right there. So let's do this. Let's see if they're looking for this. Network 209.165 dot, and of course I covered it up. .165.200.224. 0.0.0.3 area 0. And I'll be curious to see if this gets us points. I'd be disappointed as well because it's not required. And one of the activities in the scaling networks course, they had you do this, but it's not required. We don't need this, and you wouldn't typically do that because we've got a default route that's going to bring us up here to router 1 anyway. All right, so then default information originate because we're going to advertise or propagate the IPv4 default route out, and so we get some points for that. And so from an OSPF perspective, we should be done on router 1. Let's go ahead and pull router 2 up here. Router OSPF 1. We're not going to do any passive. Now, for router 2, there are going to be some specific subnets that get advertised. We're going to have a bunch of network statements here. So router 2, we've got that. Let's get our router ID in here, 2.2.2.2. Advertise specific subnets. Do show IP interface brief, right? And this is where it's going to get fun because we have to, let me scroll that back because I want to see the subnet masks, right? Because we're going to have some wildcard action going on over here. So the first one, let's just take them in order, VLAN 1 first. So the network is 192.168. This is the easy part, right? Because they give us the network ID that we need. Now, the wildcard mask. Remember, when sorting out the wildcard mask value, you're taking the inverse of the subnet mask in dotted decimal notation. Well, Travis, how do we get the inverse? Well, you simply subtract the subnet mask, the dotted decimal notation of the subnet mask. You subtract that from the all 255s. And so you would do 255, 255, 255, and then 224. And that gives me 0. I just put a dash there instead of writing 255 again 3 more times. So 0.0.0.255, right? If you subtract 224 from 255, we get 31. And so that will be our wildcard mask, and I'm going to leave that stuff up there while we put these in. 0.0.0.31, and it's in area 0. And we should go from 75, we should see a little bump in points there, to 76. So now the next network statement is VLAN 15. So network 192.168.1.0, right? And this is a /26. And we know that the dotted decimal notation for this was 128 because it's right there. So 225 minus 128 gives us 127. 0.0.0.127 area 0. So we should end up with a point for that. I hope. Yep. All right. Now we're going to do VLAN 25, right, which was 192.168.1.128, right? Remember, we had worked that out to .128, and I've got that written over here on the side. And the subnet mask was 255 dot. It was a /26. We borrowed 2 of the host bits and flipped them to network bits. And so a /26 would have been 255, 192. So 255, if we come back to our equation here, 255, and I'm just doing the last octet, take 255 and subtract 192, what do we get? We get 3, and then you got to borrow your 1 over here, and you get 6. You get 63, right? So that will be, .63, area 0. Then we've got VLAN 99, network 192.168.1.224, and we've already had a .224. It was VLAN 1 that we were working on, so we know that the subnet mask, which is right above there, is going to be 31 area 0, and we can confirm that when we jump to 79 points, hopefully there. Yep. Now, excuse me, let's not forget 10.1.1.0, right? We need to run the OSPF process on the link between router 1 and router 2, and here is where we should see our adjacency form between router 1 and router 2. And we don't see a message pop. There we go. Okay, good. It took it a second there. Typically, packet tracer's pretty quick for the adjacencies forming. So now we've got the adjacency. So now we can say do show IP OSPF neighbors, right? I should see router 1 is my neighbor with the router ID 1111, right? Do show IP route. Do I see a default OE2, right? OSPF type 2, and there it is right there. Right, and so we see that everything looks good there. And remember the default seed metric, right? When we redistribute, which is what we're doing there basically, is we're basically redistributing a static default route into the OSPF domain, which is why it comes in as an OE2. The default seed metric when going from static into OSPF is 1. Right, which is different from the default seed metric if I was to redistribute from a different routing protocol. Okay, and we've got that done. I think that is it. So we are 20 points out here, and we're going to configure IPv6. All right, so let's do that on router 1 and router 2. So we'll come back up here. We'll start with router 1 first. So how do we do this, right? We say IPv6 router OSPF process ID is going to be 1. Remember, process ID is locally significant. And we forgot to say IPv6 unicast routing. So we need to enable unicast routing. Then we can come back and say IPv6 router OSPF 1. The router ID, right? Because these are separate processes. The router ID can be the same between v4 and v6 on the same router because they are mutually exclusive OSPF processes that are going to run. And then what do we need to do to enable IPv6? Is there a network command here? There is not, right? Remember that. No network command is going to show up. We need to go under the interface, serial 000, and we need to say IPv6 OSPF 1 area 0. And that should, oh, that was a 3-pointer there. Good. All right, so that takes care of OSPF on, I'm reading through here, I keep looking down, process ID 1, area 0, configured on the appropriate interfaces, and we got the router ID. Okay, so down to router 2, where let's make sure we get IPv6 unicast routing configured, and then we're going to say IPv6 router OSPF, whoops, OSPF, oh boy, OSPF1. And we'll get the router ID set to 2.2.2.2. And now we're going to transition under the interfaces. So do show IP interface brief. So we've got quite a bit of work to do here, right? So we're going to go to gig 00.1. And the nice thing will be after we run this command, OSPF1 area 0, after we do that command one time there, right? And that's a 3-pointer. We do that command one time. Now I can just hit the up arrow to do it again, right? So we'll go interface gig 00.15, up arrow to get to that IPv6 OSPF1 area 0 command. Interface gig 00.25, up arrow. Interface gig 00.99, up arrow. And I'm hoping that takes me to 97. 96, and that's not a good sign because I don't think we're going to get serial 00. I don't think this is going to be a 4-pointer. So it looks like we may be dropping a point somewhere here because that is probably not a 4-pointer. And the adjacency is up. And we got 0 points for that, in fact. Okay, so we are missing 4 points. So let's see, what is it that we overlooked here? And everything looks dynamic mode. Fast Ethernet 02 dynamic mode, gig 01 dynamic mode. Okay, so it looks like, okay, so I'm assuming that they wanted us to make those, to take them out of, we dropped them, so here's what's going on. So 02 and gig 01, and let's go Cisco and go and enable for class. So I'm going to say global config, interface range, fast Ethernet 02, comma, gig 01, because it looks like those are the only 2 points. I believe they wanted to say switch port mode access here, possibly. And let's see if that 96, because it says dynamic mode, or if they're looking for a switch port no negotiate. Yeah, okay. Good enough. So they wanted us initially, and let me do a do show run to round this out here. What they were looking for was initially when we configured these ports, right, on this step here, right here, it said they should be properly secured and assigned to the black hole VLAN. So properly secured is shut down, right? Placed in the black hole VLAN, we did that, but they were looking for us to also say switch port mode access, to flip them to access ports. And so we took care of that. So oversight on my part, no question. But that is it. So that is going to wrap up the Chapter 2 Skills Integration Challenge 2.5.1.2. So be sure to take a look at anything that had you confused on this assignment to make sure you have that down, because this is going to look very similar to your hands-on final exam at the end of the 8-week term. All right, guys, thanks for watching. I will see you on Tuesday night. Have a great weekend.